Welcome back to the third part of our procedural rope bridge building series in Blender 5.2 geometry node. In our previous session, we converted our curve-based bridge framework into a strong 3D structure. We added thickness to the ropes, created dynamic support pillars, and made sure the pillars automatically followed the bridge length, width, height and curvature. Now in this session, we are going to add one of the most important visual element of the bridge, the wooden walking planks. Until now, our rope had ropes and pillars, but it still did not have a proper surface for someone to walk on. In this part, we will create a procedural wooden plank system that automatically follows the shape of the rope bridge. We will start by creating a single wooden plank using a cube. But instead of keeping it perfectly straight and artificial, we will use set position and noise texture to slightly distort its shape, giving it a more natural handmade wooden look. We will also add subdivisions so that the noise deformation has enough geometry to create visible variations. After building one plank, we will turn it into reusable node group and then distribute it along the bridge using instance on points. We will use curve to point so that we can control how many planks appear on the bridge, and we will connect the plank rotation to the curve direction so that every plank follows the hanging shape of the rope. Then we will define the system further. We will remove the first and last planks using delete geometry and endpoint selection, so the planks do not overlap with the support pillars. We will also introduce random value and vector math to add subtle rotation variation, making the wooden plank look more natural and less mechanically perfect. The most powerful part of this session is that the plank will become fully parametric. When the bridge width changes, the plank width will update automatically. When the bridge length changes, the number of planks will increase or decrease automatically. We will also expose a plank density control so the user can decide how closely the planks are placed. By the end of this session, our rope bridge will become much more believable. It will have thick rope, dynamic pillars and flexible wooden walkway that responds to the bridge controls. This is where our procedural model starts feeling like a real bridge system, not a fixed object, but a smart asset that can rebuild itself based on length, width, curvature and height. So let us continue and build the procedural wooden plank system for our rope bridge. Let us start by launching Blender. I have Blender 5.2 shortcut on my desktop. Double click to open it. Once it opens, in our previous session, we were working on this bridge2.blend file. If you are continuing from the previous session, you can directly launch this file and start working on it. But if you have come to this video directly, then you can come to YouTube video page or the e-learning page and you have a link to the Patreon page. If you come into this Patreon page and if you scroll down, you have a link here, bridge2.blend. Click on it to download it. And then in Blender, open this bridge2.blend file. For this session, I am going to go to File and choose Save As, and I am going to give this the name as bridge3. I am going to save this. Apart from incrementing my file with bridge3.blend, I can also create a copy of my geometry node. So right now, I am using the geometry node bridge1, and on the right side you have a list. I have only bridge1 now. I will click on this duplicate button and this is going to create a new copy of this geometry node, and I am now going to call this as bridge3. And in the list you have now both bridge1 and bridge3, and I am going to select bridge3. I have the group input here. You have rope curve, width, height, curve to mesh and curve mesh. These 5 represents my row, and below I have this multiply, pillars and then instance on point and endpoint selection. This represents my end pillars. For this session, I am going to create the wooden planks. So to start creating this wooden plank, I will move up, press Shift A, and in search, I am going to search for a cube. And right now I am not seeing the cube in my viewport because it is not connected to my geometry output. Come to this geometry output and temporarily disconnect it, and I will bring it next to my cube and I will connect this mesh to the geometry output. So now I can see the cube. If I press numpad period, it will get zoomed. Coming into this cube parameter, the y determines my bridge width. I will set its width to 4 meters, and in x, I will keep it to around 0.6 meters. This is the width, and thickness along z, I will keep it somewhere around 0.2. I have one plank of wood. The natural wood planks that we use on this bridge are not perfectly shaped like this cube. Shape will be totally distorted, and to create this uneven shape, I will come into my geometry panel and press Shift A, and in search, I will call for a node called as set position, and I will add this set position between the cube and the group output. Now basically what set position is going to do is, it is going to move my cube and set it at a different position. So right now I set all these values to 0. Instead of moving the entire plank, I only want to move these vertices in my plank. I will come into my geometry panel and press Shift A, and in search, I will search for a node called as noise. I will add this node. If required, I will zoom it out. I will move this cube with Shift press set position and group output little to the top here. Then I will add my noise texture here. I will keep it below this cube here. I will take the factor output from this noise texture and connect it to offset. Now as soon as I connect it, if you press numpad 1 and come into the front view, if you disconnect it, see it is exactly at the center, but as soon as I add this factor, see it moves up. The reason why it is moving up is the noise texture value changes from 0 to 1. However, the range of 0 to 1 should not be from 0 to 1, but to keep it at the center, it should change from minus 0.5 to 0.5. I will now move this group output set position. I will press Shift A, and in the search, I will now search for a node called as vector math. And in this vector math, basically in this noise texture, instead of using factor, I will use color. I will take color, and instead of connecting it directly to offset, I will connect it to the vector of my add, and from this add, I take the output and connect it to my set position. And then in add, I will select all these 3 vectors, and I am going to add 0.5 in all the directions. So I will type 0.5. Oh, sorry, not 0.5. It should be minus 0.5. So I will select it and type minus 0.5, and now this will be placed exactly at the center, and you can see how this plank looks. Now even in this noise texture, you have various types of textures here. Currently it is set to FBM, so you can use multifractal, ridged multifractal, or hybrid multifractal, or heteroterrain. So right now I'll use FBM only, and only thing here is I want to tweak this value. I will just set the scale to something like 0.1. There should be very little distortion here, and detail I will leave it at 2 only, roughness at 0.5, and then distortion also I will leave it at 0.5. But here I am not seeing much of the variation here because my cube does not have too many subdivisions. So I will just move up into my cube, and in this vertices there are only 2 divisions. So I will select x-axis, I will set a value of 6. Along the z-axis, I will leave it at 5. And most importantly, I need more divisions along the y-axis. So I will set the y-axis to something like 20. And you can now see slight variation in wood plank. And finally, I will come here next to set position. Before this group output, I will press Shift A, and I am going to search for subdivision surface. So I will add this subdivision surface here. I will leave the level at 1. So this default values appears to be fine. This appears like a real wooden plank. I now want to connect this wooden plank with the rest of my geometry. So I will just zoom out. I am going to take this that is coming here. I will select this and place it little to the top. So I will bring this group output down. I will remove off this group output. I have two outputs coming. So now to join both of this, I will press Ctrl Shift and with right mouse click, I will drag this output and this joint geometry here. Both of them are joined together. I will take this output and connect it to the geometry output. I will come to the top here and all these 5 nodes that is creating this wooden plank. I will select all these 5 nodes and then press Ctrl G and I am going to group it. I am going to call this group as wood plank. And then I will press tab to come back to my bridge 3 geometry node, and this wood plank will keep it a little to the down, and I have 2 joint geometry now. So one is joining these two and the third is joining here, and I will just zoom in. I can see that whether I can join it directly here. Okay, so this is possible. I can directly connect it to the joint geometry here and delete this joint geometry and connect it directly. Instead of adding 2 joint geometry, I have this joint geometry in which I am getting the curve mesh also here, the pillars also here, and the wooden plank also here. All the 3 are joined here, and I am getting the output. Now for this wooden plank, I need this wooden plank to sit on this rope. Just like we did with this pillars, I am now going to come here, press Shift A, and I will search for instance on point, and I will select this instance on point. I will just drag it a little to the top. I will drag this wooden plank, and between wooden plank and joint geometry, I will add this instance on point. So this is getting connected to the points, but actually these wooden points are not points, they are instances. And for point, I am going to take the output from my rope. If I take the output from heights and connect it to points here, it is creating these instances on all the 4 ropes. I will disconnect it from here. I will take it from width like last time and I will connect it to the point, and you can see that on both the bottom ropes you are seeing the instances, 2 rows. I doesn't want this to happen, so I will disconnect it. I will take the output directly from this rope curve. I will take the output from this and connect it to the point, and now you can see that it is placed exactly. It is very important that from where you are taking the point. So right now I am taking these points directly from my rope curve. For these pillars I took it from width because I needed 4. You have so many wooden planks because we have divided this rope curve into 40 counts. So if you select rope curve and press tab, and if you see it in resample curve we had set it to 40. So if I again set it to 5, you will have only 5 planks. So I will set this back to 40, press tab. I need a way to control this. If you see these planks, you can see it is appearing like a step, and also I have no control on the number of planks. I want this to rotate in the angle of my rope. And for this purpose, whatever output I am taking from this rope curve and I am connecting it to the point, and in this path I am going to add another node called as curve to point. So I will press Shift A and in search, I will search for curve to point. So I have this curve to points node, and I will connect it from the rope curve to this curve to point, and from curve to point it is going to the point. I can control the number of planks that I am using. So it is set to 10. I can make it 3 or I can make it 8. I can control it over here. I want this to be rotated in the angle of my rope. I will place the wooden plank just right here. I will take this rotation from curve to point and I will plug it to the rotation of instance on. Now it is rotating, but the only issue I have is it is rotating in the wrong axis. So to fix it, I will move this curve to point little to the down. I will select all these 3 nodes at the top, move it slightly to the side, and after this instance on point, I will press Shift A and add another node called as rotate instances. So you have rotate instances. I will connect this rotate instances after instance on point. And now every instance will be rotated. So along the x-axis, I doesn't need any rotation, but along the y-axis, I will rotate it by 90 degree. Okay, so the planks are looking correct. And also along the z-axis, I will rotate it by 90 degree. And now you can see my planks are following my row. See, it is moving along the row. I will go to File and save this. Now, one thing that I doesn't want here is, if I middle mouse click and turn around, I have a plank at the starting vertex here and the beginning and ending vertex here. I doesn't want this plank. I want to remove only these two planks. Before this curve to point, that is, I am taking the rope curve outward, I am going to add another node here called as delete geometry. So I will press Shift A and in search, I will search for my delete geometry and put it between this rope curve and curve to point. I am taking my rope curve output and I am connecting it to this delete geometry, and all my nodes are deleted. Now I want to delete only the first and the last one. So if you remember, we had used the same thing in our previous session. If you come down in my pillars, I had used this endpoint selection to add instances only at the end. So I select this endpoint, press Shift D and duplicate it, and I will bring it up near this delete geometry. I will take this endpoint selection and I will connect it to the delete geometry selection. Now what is happening? Only the end vertices are deleted. So if I change the unit to 2 here, 2 points at the end are deleted. Or if I use 3 here, see the 3 points are deleted. At the end, whatever vertices I have is getting deleted. So now here in the curve to point, when I change and when I increase or decrease the count, this is going to happen within this range. So in the endpoint selection, I will set the start size to, say, I will even make it 4 and endpoint also 4. Now this looks perfect. Now next, in this kind of village side rope bridges, you will not see this plank so neatly arranged. So these planks will be slightly distorted. So some will be tilted a little, some will be tilted on the other side. Where are we doing the rotation? If I place it above, I will place wooden plank a little to the top, and from this curve on point to the rotation, in between this, I have to add variations. I am going to introduce you to random value. So I will press Shift A and come into the search, and I will search for random value node. This random value that is coming is a float number, but here I need a vector. So in the random value, instead of float, I will come and select vector. I want this random value not to be directly connected here. I want it to be added to this rotation. I will press Shift A and I will search for another node called as vector match, which is used for vector addition and subtraction. I will move all these instances little to the top to make some way here, and I will bring add in between this curve to point and rotation. I will move this a little to the top and I have add here. Now I will take this random value, whatever is getting generated here, and I will drag this and attach it to the other vector. So I will select all these nodes and I will pull it up a little to make some space here. This is creating a kind of random rotation all around, but I doesn't want this randomness so much. I will come into the random value. You have minimum and maximum. First I will set the value of the maximum. I will change the first value to something like 0.15, and the second value I will set it to 0.03, and the third value I will set it to something like 0.05. So I have very subtle rotations now. And also in the minimum, I will use the same values but negative value. For minimum, I will use minus 0.15, and for second axis, I will use minus 0.03, and for the third value, I will use minus 0.05. I have a slight amount of randomness and it appears more natural now. Now this is almost perfect. Only thing here is I want to increase the thickness of this cube. So I will come to the top here to this wood plank group, press tab to open it, and in the cube Z I will increase it to 0.4 so that it is slightly thicker. When I actually change the width, you can see my plank width is not changing. So I will set it back to 4 meters. As the width changes, my width of the plank should change. The width of my plank is coming here through this cube. I will move group input to the side, and in this wood plank group, I will press Shift A, and in search, I will add combine XYZ node. I will put it here. So before I connect it, I will copy these values to my combine XYZ. It is 0.6 meter in X, 0.4 meter in Z, and 4 meter in Y. And I will now connect this vector to this cube size. The values are coming from here. Now only thing is this width I have to control, and even Z 0.4 is more. I will put it back to 0.2 only. I will take this Y output and put it into the group input. I will come on the right hand side wood plank panel, select Y, press F2, and I am going to call this as plank underscore width. Now I will press tab, and now you can see that my wood plank has this plank width. I am now going to come back to group input. I will take this bridge width output and connect it all the way to my plank width. As I change the width, you can see the width of my plank is also changing. To organize it correctly, I will press Shift right mouse click and drag a point. I will press G and drag it and put it here. I have structured this to come to this wood plank. I want this wood plank to be slightly longer than my rope. So for that, like last time, I will press Shift A, and in search, I will add a mat node, and this mat node, I will connect it before the wood plank. I am going to select multiply, and in the value, I will keep it 1.2. The wood plank width is going to change as I change the width here. So I will set this back to 4. And one other parametric control I want here is the number of count that I have, it should increase as I increase the length of my bridge. So if I increase the length, right now this count is fixed. I want this count to increase as I increase the bridge length. I will set this length back to 10 meters. I will come into count. I am going to increase it so that in 10 meters, I find 15 planks. So for every 10 meters, count should increase by 15. I am going to take calculation from the bridge length. So I will drag this bridge length value and connect it to the count. Since it is 10 meter, I have 10 plank. Even here, I will press Shift right mouse drag. I get a point. I will press G and move it and place it here. I will place this endpoint selection to the top so that I organize it correctly. So I will move this multiply also little to the top, and also this endpoint and delete geometry, I will move it to the top. I will press Shift A, and again I will add a math node, and this math node I will connect it here, and here I will again choose multiply, and I am going to multiply it by 1.5. As I now increase the bridge length, you can see the number of wooden planks are increasing. And as I decrease it, see the number is going to reduce. So this number is automatically controlled based on the bridge length. So I will set this back to 10. So to control this density, I have added this multiply here to my count, and I will take the output value from here and I will connect it to the group input. Coming to my right panel here, I will change this value name to plank density. Press enter. See, as I change my plank density, the number of plank is going to change. If I set it to 1, it means that for every 1 meter, you have 1 plank. So if I move it, see, for every 1 meter, so if I set it to 1 meter, you will have only 1 plank. If I set it to 10, it will have 10 plank. And if I set it to 2, for every 10 meters, it will have 20 plank. And I will set it something to 1.5 so that it has 15 planks for 10 meters. So now we have successfully built this entire wooden plank system. Come into this window and see that it is correctly arranged. So I have the pillars at the bottom here. I will drag it, and in the center everything is about the rope, and on the top you have this entire area which represents my wooden plank. We have organized it correctly. I will come to File and save it. So now our next mission will be to add vertical ropes here. We are going to do it in our next session.